Welcome to the deep dive. Okay, so our sources today, they reveal something pretty astounding about Antarctica, the white continent.
Mm-hmm.
It's so much more than just this, remote frozen image we might have.
Absolutely.
I mean, our deep dive shows it's actually the fifth largest continent. It's bigger than Europe and Australia combined.
Yeah, it's huge.
And it holds, get this, an incredible 70% of the world's fresh water. I mean, that alone, just that fact is kind of wild to think about.
It really is. It's like Alejandro Barunja put it so well. It's a place where Earth is so close to its limit, it's almost like another planet.
That's a perfect way to put it. So our mission, right, for this deep dive is to really unpack what makes this place tick. This critical, but often overlooked part of our planet.
Mm-hmm.
We'll dig into its geography, the extreme climate, obviously, the unique life that somehow, manages to thrive there.
And all odds, yeah.
Exactly. And that delicate balance, too, between human activity and preserving it. The goal really is to give you a solid, well-rounded picture of Antarctica using all the great material we've got.
Sounds good.
So to really get Antarctica, I think we first need to sort of strip away those common ideas and look at what it actually is.
Right. Its identity.
Yeah. Our sources show its name. Antarctica literally means opposite to the Arctic, which, makes sense geographically. It's right there, opposite the North Pole, with the South Pole smack bang in the middle.
And that position is key. It explains so much about the extremes, especially how it's completely surrounded by the Southern Ocean.
Sometimes called the Antarctic Ocean, right?
Exactly. It's basically where the southern ends of the Pacific, Atlantic, and Indian Oceans all kind of meet and swirl around it.
Okay.
And that ocean isn't just, water. It acts like this massive barrier. It means the continent's climate is just brutal, and that dictates almost everything.
Like no permanent human settlement.
Yeah, precisely. Because of the extreme cold, nobody lives there permanently. Our sources actually call it a human void zone.
Wow.
Yeah, and even described as a virgin continent untouched by human beings and their mindless activities, which is quite evocative.
Definitely.
The only creatures you could really call permanent residents are, what some call the gentlemen in white coats.
The penguins.
The penguins, exactly. Though even they mostly stick to the coasts, needing the ocean for food.
It's quite something thinking of a place so untouched. But that isolation, it actually makes its power even clearer, doesn't it? Especially when you think about water.
Oh, absolutely. That's where its global significance just hits you.
That 70% figure for fresh water, it's not just a stat. It basically makes Antarctica the planet's water tower. Or maybe its biggest climate risk. What's the real weight of that beyond just, worries about water running out?
Well, that's the crucial point, isn't it? It means Antarctica isn't just some far-off icy place. It directly influences whether the planet is, livable. Our sources point out that the ice melt rate, it's tripled just in the last decade.
Tripled?
Yeah. And it's not just about sea levels rising, though it's huge.
Yeah.
It's also about dumping massive amounts of fresh water into the oceans.
Which does what?
It can disrupt critical ocean currents, the ones that regulate weather patterns globally.
Right.
It could literally reshape coastlines around the world.
Yeah.
So what happens down there, it really doesn't stay down there.
Right.
And then you add in the concerns about the ozone hole over the continent. It just paints a picture of this incredibly important system under, enormous pressure.
That really puts its scale into perspective.
Okay, let's dive into the geography and climate specifics then. Because it's not just one big ice block, is it?
Not at all. Our sources break it down into two main parts.
Okay.
You've got East Antarctica, which is the bigger chunk, about 2/3 of it. They call it Greater Antarctica. Think high, icy plateaus.
Right.
Then there's West Antarctica, smaller, generally lower elevation, sometimes called Lesser Antarctica.
And why does that split matter so much for, say, climate science?
Yeah.
It's vital. East Antarctica, the big high part, is generally seen as more geologically stable. It holds the vast majority of the ice.
Okay.
West Antarctica, though, the smaller, lower bit, that's where scientists are really worried. It's much more vulnerable to ice loss, especially because parts of its ice sheet are actually grounded below sea level.
Below sea level. So ocean warming is a direct threat.
Exactly. That difference in stability makes a huge difference in predicting sea level rise and figuring out where to focus research. So the split isn't just descriptive, it's fundamental.
Which explains why, even though it's covered in ice, it's actually the highest continent on average.
That's right. Average elevation over 2,000 meters. which is, like you said before, about double the average for Asia. It's quite startling.
It really is. And cutting right through this high plateau, you have the Transantarctic Mountains.
Colossal things, stretching, what, 3,500 kilometers?
Yeah, an incredible distance. They basically act as the wall between East and West Antarctica. And they've got the highest peak, Mount Vincent Massif, at nearly 4,900 meters. Plus, massive glaciers flowing off them, but also, surprisingly, these ice-free areas called dry valleys.
Yeah, those are fascinating. Almost Mars-like in their appearance.
Oh.
And it's worth remembering, the actual South Pole, that's located in East Antarctica on that high plateau.
And it's not geologically dead down there either, is it? Despite the ice?
No, not at all. Our sources mention active volcanoes, which always surprises people. Mount Erebus is probably the most famous, right on the coast of the Ross Sea. Still pucking away.
An active volcano in Antarctica.
Yeah, and Deception Island, too, which is basically flooded volcanic caldera. And then there's the Antarctic Peninsula.
The tail.
That's the one, the northernmost bit, kind of reaching up towards South America. It's the part that experiences the most, well, mild conditions, relatively speaking.
Mild being a very relative term here, I imagine, because the climate overall is just extreme.
Oh, unbelievably so. It is the coldest continent.
Yeah.
Average summer temps around minus 31 Celsius.
Summer.
Winter drops to minus 60 C on average. And the record low, down at Russia's Vostok Station, minus 89.2 degrees Celsius.
I can't even comprehend that. It's just a number that doesn't compute.
It's brutal. And despite all that ice, it's technically a desert. The largest cold desert on Earth, in fact.
Because of low precipitation.
Exactly. It only gets about 17 centimeters, maybe 6 or 7 inches of precipitation a year. And almost all of that falls as snow, obviously. It rarely melts inland.
So how do those conditions, the extreme cold and dryness, actually manifest? What does it feel like?
Well, you get those infamous blizzards, howling winds that can gust up to 300 kilometers an hour.
Yeah.
They just scour the landscape and whip up any loose snow. Visibility drops to zero.
Terrifying.
And then there are the seasons. Being in the southern hemisphere, it's all flipped for us in the north. Summer, October to February, means continuous daylight, 24 hours of sun.
Weird.
And then winter, March to September, means the opposite. 6 months of continuous darkness. It's not just a change in weather. It's a fundamental shift in the environment itself.
It really is almost another planet. How does anything survive? The sources say the land is almost completely barren.
The land itself, yes, extremely barren. Vegetation is minimal. You're talking lichens clinging to rocks, maybe some fungi, algae and damp spots.
Any proper plants?
Only 2 species of flowering plants, both types of grasses, and they're restricted to the slightly milder peninsula area. That's it for land plants.
But the oceans are different, described as engines of life.
That's the huge contrast. The land is stark, but the Southern Ocean, it's incredibly rich.
Why the difference?
The cold water holds a lot of dissolved oxygen, and ocean currents bring up deep, nutrient-rich waters. This creates perfect conditions for phytoplankton.
Tiny floating plants.
Exactly. Microscopic plants that bloom in absolutely massive numbers. They are the base, the absolute foundation of the entire Antarctic food web. Everything depends on them.
Okay, so they feed everything else. But the source mentioned something about oxygen, producing up to 85% of the world's oxygen. That seems huge.
It is potentially huge. Estimates vary, maybe more like 50% is a common figure. But the point is, their photosynthetic output is massive. Truly planetary in scale.
So the air we're breathing
could very well contain oxygen generated by these tiny plants in Antarctic waters.
Yeah. It just shows how connected everything is, doesn't it? How this remote place impacts global atmospheric health.
That's a really powerful connection. And, okay, iconic wildlife. We mentioned the penguins earlier.
The stars of the show?
Adelie and emperor penguins are the ones mentioned most. Flightless, obviously, but amazing swimmers.
Yeah.
Using their wings like flippers.
Right, and they need that swimming skill to catch their food. Plus, they have that incredible insulation, a layer of blubber maybe 20 centimeters thick, like a built-in wetsuit against the freezing water and air.
Beyond penguins, what else thrives in those oceans?
Oh, a lot. You've got krill, tiny shrimp-like creatures, but they occur in such vast numbers they form the basis of the diet for many larger animals. Super protein-rich.
Right, krill is key. Then there's squid, various fish like the Antarctic cod, and of course whales. Many different species migrate there to feed in the summer. And seals, too.
What kinds of seals?
Several types. Big ones like elephant seals, fur seals, the rather fierce-looking leopard seals, and Weddell seals, known for living further south on the ice than any other mammal.
Wow.
And while the land is sparse, you do get migratory birds visiting in summer. Albatrosses, gulls, petrels, cormorants. They come for the rich feeding in the ocean, but they don't stick around for the winter darkness.
Sensible birds.
Very. And one other interesting point, a unique absence. No reptiles at all in Antarctica.
None.
None. Too cold. And only one native insect species, a tiny little flightless midge. It's an ecosystem almost entirely reliant on the ocean.
That reliance makes the next finding really hit home. It comes from the British Antarctic Survey, the BAS.
Right, a major research organization down there.
They used satellite images and found something they called catastrophic. The emperor penguin colony at Halley Bay, normally huge, like up to 20,000 pairs.
A massive colony.
It suffered complete breeding failure. For 3 years straight, 2016, 2017, 2018, all the chicks died.
Just devastating. What happened?
The source says it was directly because of unusually warm and stormy weather. It caused the sea ice, where the penguins lay their eggs and raise their chicks, to break up way too early.
Before the chicks were ready to fledge and swim.
Exactly. They weren't waterproof yet, just lost.
That's awful. And is this linked to climate change?
Well, the BAS penguin expert, Phil Trathan, he said it's impossible to link one specific event like this directly to climate change. But he also said such a complete multi-year failure at that site. Totally unprecedented. And the big worry is, if this kind of sea ice loss becomes more common, which models predict with warming?
The penguins are in serious trouble.
Yeah. Predictions are for up to a 70% decline in emperor penguins by 2100 if these trends continue, which is why there are calls to put them on the International Red List of endangered species.
It really highlights how sensitive these polar ecosystems are, even the ones that seem so tough.
Absolutely. Okay, let's shift focus a bit to the human side of things. We know people don't live there permanently, but there's history. Exploration started early.
Relatively speaking, the mainland itself wasn't really confirmed until about 1820. Then you had the heroic age of exploration. Ronald Amundsen, the Norwegian, famously reached the South Pole first in 1911.
Beating Scott.
Beating Scott, yes. Yeah. And then Admiral Byrd, from the U.S. Navy, made the first flight over the South Pole in the late 1920s, 1928-29, opening it up in a new way.
So exploration, but still no settlements? But scientists go there.
Oh, yes. During the Antarctic summer, when conditions are slightly less impossible, about 4,000 to 5,000 people are down there. Mostly scientists, geologists, meteorologists, biologists, glaciologists.
Study what?
All sorts of things. It's a unique natural laboratory. For instance, meteorites. They fall everywhere on Earth, but in Antarctica, they land on the ice sheet and get preserved, uncontaminated. They're relatively easy to spot against the white background.
Ah, interesting. Like a collector sheet for space rocks?
Kind of, yeah. Pristine samples. And NASA has even used parts of Antarctica, like those dry valleys we mentioned, to test equipment and strategies for Mars missions, because the conditions can be surprisingly similar in some ways.
Extreme cold, dryness, isolation. Makes sense. Now, what about resources? Is there anything under the ice?
Well, explorations have definitely suggested potential. Coal has been found, iron ore, copper, and there are predictions, based on geological similarities to other continents, that there could be gold, diamonds, uranium, maybe even significant oil and gas reserves trapped deep beneath the ice.
A potential treasure chest, then, locked away.
For now, yes. But despite that potential and the science, there's also tourism.
Yeah, that surprised me. About 50,000 visitors a year. What do they do?
Mostly cruises around the peninsula, landings to see penguin colonies, that sort of thing.
Yeah.
But some do more extreme stuff, like that ice marathon, a full 42.2-kilometer race near the South Pole.
Running a marathon at the South Pole, that's intense.
It is. And here's a counterintuitive fact from the sources about danger there. It says, the most dangerous thing here is not weather, but fire.
Fire in the coldest place on Earth.
Think about it. Everything is incredibly dry because of the cold. Buildings are often made of materials that can burn. And getting firefighting equipment or help there, extremely difficult and slow. A fire can be catastrophic very quickly.
Okay, that makes a chilling kind of sense. Now, international presence. India's involved too.
Yes. India has a significant research program. Their first expedition was back in 1982. They set up the Dakshin Gangotri station.
What did that focus on?
It became really important for monitoring how the ice sheets are changing, potentially due to global warming, observing those long-term trends.
And they have other stations now.
They do. Matri was established later, around 1988-89. It's equipped for broader research, glaciology, meteorology, even medicine in extreme environments. And their newest one is Farathi, set up in 2012.
What's special about Farathi?
Its location is interesting, near a mountainous coastal region. It focuses more on oceanographic studies and understanding the processes of how continents break apart. looking back at geological history. So India has a pretty comprehensive presence.
Alongside other nations, like the U.S. with McMurdo Station?
Right. McMurdo is the largest base on the continent, kind of like a small town operated by the U.S. Many countries have research stations there.
Which brings us to maybe the most remarkable human aspect, cooperation, the Antarctic Treaty.
Ah, yes, the treaty. Signed back in 1959. Really a landmark agreement.
By 12 nations initially.
12 original signatories, yes, including countries that had territorial claims down there, like the UK, Argentina, Chile, Australia, and also the U.S. and the Soviet Union, right at the height of the Cold War. India joined later.
And what does this treaty actually do? What makes it so special?
Well, its core principles are pretty incredible. First, Antarctica should only be used for peaceful purposes. Absolutely no military bases, no weapons testing.
The demilitarized continent.
Exactly. Second, freedom of scientific investigation. Countries should cooperate and share their findings freely.
Open science.
Pretty much. Third, conserving the living resources, protecting the wildlife. And fourth, a ban on nuclear explosions and the disposal of radioactive waste.
So science and peace, but what about those minerals we talked about?
That came later. The original treaty didn't explicitly ban mining, but concerns grew, and in 1991, an additional agreement, the Madrid Protocol, was added.
And that did what?
That specifically banned all mining activities for at least 50 years. A huge step, basically putting environmental protection and science above resource extraction, at least for that period.
A 50-year ban from 1991. That takes us to 2041. Not actually that far away now.
Exactly. The clock is ticking on that provision.
Okay, so let's try and pull this all together. What we've seen is Antarctica as this place of just huge contrasts.
Definitely.
Prominently frozen, looks desolate, right? But actually, it's this vital engine driving global climate. It's a cutting-edge lab for science.
A fragile ecosystem facing real threats.
And somehow, also this symbol of international cooperation working against the odds sometimes.
It really forces you to think about how interconnected our planet is, doesn't it? Even the most remote place imaginable has these direct, massive impacts on everyone.
Yeah. And that really sets up the final thought, the big question moving forward. We see global warming changing things rapidly, even down there.
We see the impacts on the penguins, the ice melt accelerating.
And we know that mining ban from the treaty has an end date, 2041. So the question really becomes, how do we as a global community handle what comes next?
Right.
How do we balance the push for scientific knowledge, the potential temptation of resources under the ice, and the absolute need to preserve this unique, critical white continent for the future?
It's a massive challenge with no easy answers.
Definitely something for all of us to think about, wouldn't you say?